φανταστώ.
Φτιάξει, ναι. Αυτό εδώ πάνω είναι ύψωμα, είναι σκάλες δηλαδή προς τα πάνω.
Ναι, από εδώ τελειώνει να φανταστώ.
Αυτό να πούμε ότι
Okay, is anyone out there? Okay, so I'm gonna get started. A reminder for anyone watching this video later on, you do not need this. It's not a requirement that you use it. I'm just going through it because it was requested on Discord. Right. So I have a VM similar to what you should have created for this class. I do not have a custom version of the kernel, obviously. I just installed the one available on the repositories. It's 5.8. We don't really care about that though. Let me see what web browsers do we have here. Okay. Firefox, sure. Having trouble? Yeah, no, I don't care. So we'll need a few things. I want to install VS Code. I also want to install, well, I'm gonna need Google Test. Right, so this is the repository for Google Test. You can find all of the documentation and stuff in here. And obviously I cannot go over everything. You can use, so they have some UI frameworks and stuff to run their tests directly if you want to. I won't be doing that. I will be integrating some of it in VS Code. So download the Debian file, the Deb package, save it. And Firefox was here, so I used Firefox. I don't really care. But it would be nice if it gave me a notification that the download finished, or something. Anyway, of the terminal. Download. This is the file. So sudo apt install load file. This is taking a while. Why? Oh well. Okay, now we have VS Code. There you go. That's it. That's all of the difficulty of getting VS Code running inside your VM. We're gonna need one more thing, which is gonna be installed CMake. CMake is a build system that can generate files like make files or Visual Studio solution files and all of that stuff. CMake is a generic thing, and you can generate platform-specific compilations from that. And the reason we need it is that Google Test can be compiled with Bazel or CMake. I tried to understand Bazel, I couldn't. Or you could make it manually compile if you wanted to, but yeah, good luck. Right, VS Code. Oh no, CD home. Let's make directory test example. Open up code in here and go to our extensions. We're gonna need the C++ extension, the one from Microsoft. And we're also gonna need CMake support. We are gonna need CMake tools from Microsoft and the CMake support from TWXS. Once all of those have been now, we're gonna reload the window just to be sure. Okay, perfect. I think we're ready to go. By pressing Ctrl and tilde, we can open up the integrated terminal, and we are gonna make this folder into a repository. Repository. Let me see some of my stuff. Wait, what? Okay, so now that this is a repository, we are gonna add a submodule. A Git submodule is another repository that you want to use in your code, but you do not have to actually put that code into your repository. You just create a link between your repository and the external. Let's see, Git submodule add, does this help? The repository, so we need the repository and then the path. So git add the repository is the repository for Google Test. Damn it, again. The repository for Google Test here. Did that. And the path, I'm gonna put it in extern for external or dependencies or whatever you want, and Google test. And now it cloned everything. Now, if you were to push this, it would push the whole Google test code as well. You do not want to do that, ideally. So we'll make a git ignore file. Touch.git ignore. If I could spell it correctly. Git ignore. And in git ignore, we're gonna add the extern directory. So we'll not be pushing all of this code into our repository, but it is part of our repository. So if we clone it with the recursive command right now, it's going to take all of those. Yeah, this will probably be instead of proj2 tests, like this test example directory. Okay. So this is all of the setup that we have to do. Let me see now in here, let's say you want, so you'll probably want some folder hierarchy here, something, I don't know, right, that you can set this up however you want. So for instance, you could do something like, I don't know, let's say source, and sure, in here you have a directory called common, and inside common you add your this run pairs.h run, and in here you can actually define the stuff. Let me see the one that Joe gave you, for example. Oh yeah, I have to enable copy paste. So shared clipboard bidirectional. Copy again, paste. There we go. Okay, so yeah, this looks okay. Obviously, I do not have all of these system calls, right? So anything we write is going to return InnoSys right now, but you know. Okay, in source, let's create, let's say, another directory and call it tests or something. And in here, we're gonna have a single test right now called sanity. We can make this a C++ file. It's what do you mean you should have the wrappers elsewhere too? Because this is gonna, the wrappers are inside source common. See over here on the left, source common syscall wrappers. Git ignore is only ignoring the extern directory. Source and extern are next to each other. They're sibling directories. Okay, so now we have to actually tell CMake what to do with, you know, the disaster we just built over here. First of all, we need our main CMake file. CMake uses these files called cmakelist.txt. Same as you had your root project file, for instance, your root make file for the kernel. This is the root make file for your tests, let's say. Okay. First, we are gonna tell it that we need a minimum of version 3. That's the newest stable version of CMake. There is actually, I believe there is even a 4 one, but I'm not sure, but there is definitely 3.8 one. Then we are gonna declare a project. The project. Okay, I don't know. Give me a name for this project. What is the delay here on the settings details? Trainwreck works for me. So we have a project name Trainwreck. Next, we copy paste this line even if we do not need it. So CMake has a thing called modules, which are basically plugins for the whole build system. Those plugins can do pretty much anything you can imagine. You can find some pre-made, you can write most of them on your own. What we are gonna use it for, maybe, is to search for specific libraries that are installed on the machine. But also right now I'm not sure I'm using it, but honestly it's a good thing to always have this in your CMakes, just so you can have this CMake modules directory to add whatever you want in there. Alternatively, you can have this where it will append this thing into CMake module path. So whatever it was by default plus this thing. Either or. And obviously you can actually change where this points to for your project requirements. I don't think we'll use it for this example, but it's a good idea to have. Next, we are gonna add a subdirectory, and the subdirectory is source. So again, to get a visual, we are editing this CMake lists here, and source is a sibling of this. So you just add the relative path here. And what this says is, okay, I know that this folder contains stuff that I care about. That stuff can be other projects, can be libraries, can be executables, can be, I don't know what, it can be literally everything. All it says is, okay, go in there, see what other CMake list files I have in there, and deal with them. And now, specifically because we want to be using unit tests, we have to enable testing. We have to include Google Test, and I made a mistake. So source is going to be using Google Test, so we have to include source down here. Okay? After we include Google Test and we enable testing. Now, this doesn't really say anything to the system, but we'll fix it soon enough. All right, next, let's go into, I guess, tests. So here in source, we add a new file, CMake list.txt. Now we need to tell the build system what this thing is, this directory. Okay, now I'm gonna be copy pasting a lot because there is a lot of things that we have to do here. I think you can find most of what I'm gonna be copy pasting in the actual documentation of Google Test. Right, because that's where I found it. So again, minimum version that we want to be using. And now add the subdirectory. But the subdirectory is not actually a subdirectory of us, it's a parent directory. We don't really care about that. And we add it as extern Google Test. This is how, when we did the include Google Test, this is how it's gonna know what the hell Google Test is, because we are adding this definition here. Now, okay, all of those here, as you can see, they're linking against the extern directory. If you change the name of this folder, you should be changing it in here as well. And now we are defining a macro. This macro will take a name, and well, this here should be changed to Trainwreck. Oh, actually, it shouldn't be changed. Never mind. This was from my own changing. Yes, this thing. Okay, it will create a new executable. So its test collection is gonna be an executable now. So you'll have multiple executables, not just one. You have to link against these libraries in order for Google Test to work and to be able to use it. Yeah, this discover test is something from Google Test itself. So yeah, basically you can just copy and paste this code. And up until now, the only thing that you would have to change is extern here, the references to extern, if you change the folder extern up here on the left. Now we change where all of our executables are gonna end up. So we say that all our executables are gonna be in CMake source directory, which is the same directory as the root file. Then bin, then Linux debug or Linux release or stuff like that. So you normally CMake will generate a bunch of files, and you will have to go searching through that to find the actual executables. If you do that, all the executables are in one place, and you can just go. And so now we need to add the sanity test. So let's use the macro that we just defined up here. The macro is package add test. Package add test. Let's give it a name. Let's say sanity test. And which source files this thing is gonna need. Same way as in your make file, you had to add all the source files in there. You're doing the same thing in here. So I named it sanity, right? Yeah. Sanity.cpp. And this is it for the setup, I think. Let's go write our sanity test now. First, we have to include Google Test itself. Keep in mind that you are including it as relative right now. You're not including a global library with the angle brackets. You also probably want to include one directory app, common, Cisco wrappers. Let's get our main function done. Okay, so this is the main function. You shouldn't have a reason to change it, to be honest. Now, what you need to do is define tests. The way you do it is with the test macro. First, you give it the name of the collection. So let's say sanity checks, comma, and then the name of the test. The name of the test should be describing the test case. So in here, let's say that true equals true. And in order to test it, expect. This is a macro that comes from Google Test Now. You can find all of those in their documentation. Expect equal true, true. Now, at this point, if you are using the command line CMake, you can use CMake from here, set CMake from here, and you can read up their documentation on how to actually compile all of that stuff. What I'm gonna be doing is CMake configure in here. I want you to use GCC 8.3. Gonna wait a bit for it to configure everything. And we got an error. Wonderful. Cannot find. Oh, yes, because it's not sanity CPP, it's tests sanity CPP. So if we go in here, we can linearly configure all projects. Generating done. So over here right now, as you can see, I'm in the CMake tab. It has generated a bunch of targets. What you care about, as you remember, we named our project as Trainwreck. And it has a bunch of stuff here. What we care about is source, and now you can see our one target here, which is this thing, sanity test. You can open it up and see the actual files if you want to quickly edit them. But most importantly, you can either right-click build, run in terminal if it's already built, or the best part, you can right-click debug. It's gonna take a while to build. Oh, please tell me I have GDB installed in here. I might have forgotten to install GDB. Let's see. Okay, never mind. Yes, I wanted to continue. Yay, now we have GDB. Let's try this again, shall we? Debug. And we are already executing. Execution has stopped in this line. We could also add one more breakpoint in here. And I don't know, let's say hit continue, and then it will stop in here. You have all the local variables, that's the automatic stuff that GDB detects. And you can also specifically ask it to watch stuff in here. And so you could ask it to watch for a variable that we no longer have. You could ask it to calculate some expression for you. This could be actually a programmatic expression, right? Like a pointer address. So the original plus an offset, something like that. Let me see what else. And basically this is the reason we wanted you to start with a user space prototype, so you can do this with your prototype, not the testing but the actual debugging. Instead of spamming printfs everywhere, you could break into here and inspect values and see what everything is. Alright, I'm gonna stop debugging this one right now. So let's say you had a create system call, right? So the way you would do it, new file and create tests.cpp. You can copy and paste this basically. You can add it here. Let's say create tests and create tests.cpp. Sure, we added it, and now each test should be testing one thing specifically. It would be good for you to add an extra system call at the end, which is gonna reset the system completely. It doesn't care about root permissions, it doesn't care about anything. All it does is it frees all the mailboxes, all the data, all the names, everything, and resets everything to a pristine condition. That way you can like set up here. Setup could be creating a mailbox or creating names, stuff like that. Execute. This is calling the actual system call now. Verify, check the result, and at the end, you call that system call and you shut down that system. So the next test starts from scratch. And so let's say this was, let's pretend that we can actually use those headers, common syscall wrappers. Oh, actually, this is not valid in C++. My bad. So name, let's say test box. What did we call it? I know, let's say 50. And if this test, let's say in this test, you want to test that it actually created something. Okay, you name it, creates the mailbox. For example, verify. If it did create, you should expect the return value to be equal to what is the number that the system call should return if it successfully created the mailbox? 0. So expect RV equal to 0. I do not have the actual shutdown system call, so let's pretend I call it here. This is one test. Let's have a second test. Now create returns inosys, because create doesn't exist right now. So I can include erno to get the values, expect RV to be equal 1, and actually, better. Expect EQ air with Enosis. So if I go back to here and reconfigure everything, create tests is now here. I can build it, will compile, I can run it in terminal or debug it. And if I run it in terminal, you see I got a nice report with pretty colors. Print keys are simple enough. Okay. As I said, you do not need to do this. And print keys are not enough, trust me. So as you can see, sanity check creates mailbox, it ran and it failed because obviously like I was expecting RV to be 0 but it's -1 because there was an error. But create returns InnoSys ran and succeeded because it did return InnoSys. No, it wouldn't be negative InnoSys because the errno is positive always. And so when you return a negative value from your system call, the syscall function will add that as a positive value to the errno global variable. But if you ever wanted to do real testing, Oliver, this is what you would be doing. You wouldn't be using printfs and stuff like that. This is how testing happens. Okay, and you can check its condition individually. So you have create error returns null when returns if fault when name is null. Create returns if fault when size is, well, that's not true. Let's say for read returns if fault where data is null. Read returns, right? And test each case individually. And then when you just run it, it's pretty easy to see the red part and be like, oh yeah, this is no longer working. Now you know what you have to fix. And this is it. This is the setup. Now, as you can see here, it has generated a build directory, a bin directory. So ideally, you would add all of those into your git ignore. So you add the build and bin directories, because we don't really care about all of that stuff. That is stuff that has to do with your compilation. You don't need to add that into the repository. Same with all your .o files or your simple cell executable. We don't want that. We're not going to use that. Right, that's it. Let me see if I can find the command. Actually, if I look at the log here, CMake launch. Okay, let me do a clean reconfigure all. Can I see the? I'm trying to find the actual command. Oh, well, I couldn't find it here, so let's search it. CMake. Wiki. Now, there are more things that you can do with CMake. You can add it to the CTest suite, and VS Code would give you a report on how many tests were run. See, down here it says run CTest, but there's no CTest actually. And it would automatically tell you which lines of code were tested from your code and all of that stuff. Yeah, that's getting a bit too much, to be honest. But you could definitely do it. CMake documentation. Ooh, the latest one is 19. Okay, CMake tutorial, let's see here. Okay, so the way you would do it is actually, let me open up another terminal and go there. CD. So let's say, let's remove the build directory. Okay, so let's say we want all our artifacts to be in the build directory. Let's make that directory. Build, build. And then we want to CMake in order to generate the root file, which is one directory up. So the one in test example. This will auto-detect stuff and it will place all the generated stuff in your current directory, which is test examples build. That's why we went into build first. Right, so it has a bunch of stuff in here. Oh, why is this not zooming in? Damn it. Can you read my terminal? Okay, so all of this stuff is in build. So now you can do CMake -build and where to find all the build files in the current directory. It will start building. This is the same we were doing with the configure options and stuff from the menu here. Right, so now if we go back, we have the bin directory here, so cd bin. We have Linux _. This is the one that was just generated because I didn't define my compilation mode. While previously I was compiling in debug mode, so cd Linux. Oh yeah, you don't get autocomplete with bus. And as you can see in here, we have the two tests, the two executables. Green means executable in default bus. And the way we got this directory, bin and this name, if you remember in here, we said that, where is it? Here. The executable output path is going to be the source, then bin, then the system name, Linux, then the build type. The defaults are debug, release, release with debug info, and minimum size release. And that's it. You could move those into a different folder if you wanted to be more accessible to the TAs or something like that. This is the setup. Yeah, as I said, test one thing each time, and then you could even make some integration tests, they're called, where you actually open up a mailbox, read and write to it, and verify that the return of what you read is what you wrote initially. And have a shutdown or something system call for your own use and your own test cases. So you can verify that you are starting from scratch and you do not rely on existing behavior. That's it. If you have any questions, I can take them now or we can call it a day. But it will just clean out the whole system. That's all the shutdown is. It doesn't care about, root permissions and stuff. It just cleans out every mailbox. Or you could even add some other system calls that create a pre-existing state specifically controlled by you so you can use that in your tests. That's also fine. We'll just, we will never call those system calls. That's why you have to have them after the ones that we gave you. But for your tests, it's okay to have extra system calls to help with the testing. Okay, thanks for coming, everyone. Good luck with the rest of your project.